Hello, welcome to the tutorial on random forest. In our previous course on predicting the building energy demand, we found random forest provided a better accuracy than support vector machine model. So in this video, we will explore how random forest model works and why it performs better than other models. In addition, we will see how can we further improve the performance by tuning its hyperparameters. So to begin, we need to understand decision tree and ensemble learning. So decision tree is a kind of tree where root node or root is repeatedly split into smaller nodes based on different features. Final nodes are called leaf nodes or leaves. In between, these are internal nodes or called only nodes. Decision tree works well with the data used to create them, but they are not flexible for new dataset. So now, what is ensemble learning? How does it work? So different models may be good at different parts of data, and the errors of models can be averaged out in case of overfitting. So ensemble learning is the collective learning of several models. So what is random forest? Random forest is an ensemble of decision trees where many trees are constructed randomly and form a random forest. It can combine the simplicity of decision trees with flexibility and can result higher accuracy. So how does it work? Each tree is created from a different sample of rows, and at each node a different sample of features is selected for splitting. And each of the trees makes its own individual prediction. So like this in figure. And these predictions are then averaged to produce a single result. So let's look at these figures for a better understanding. Every tree is learning from the data in different ways, and in the last figure the random forest model is combining all the learning and providing a better prediction with lower error possibility. So when a random forest is the effective model, when the data has a non-linear trend and extrapolation outside the training data is not important. So let's start with the hyperparameters. All the estimators have parameters to tune for improving the performance. The Python library scikit-learn provides tools to automatically find the best parameter combinations via cross-validation. So what is cross-validation? It is a resampling procedure used to evaluate machine learning models on a limited data sample. A given data sample is split into a number of groups as training and validation sets. In this figure, we see five-fold cross-validation where 5 experiments are conducted to evaluate the model performance. So, what are the hyperparameters of random forest? Here we will see only 6 main parameters. 1. Number of estimators, which is the number of trees in the forest. The default value is 100. Maximum features. This is the maximum number of features considered for splitting a node. The default value is auto, which is equals to the total number of features. The maximum depth, which is the maximum number of levels in each decision tree. The default value is none, which means the nodes are expanded until all leaves are pure. Then the minimum samples is split, which is the minimum number of data points placed in a node before the node is split. The default value is 2. Then the minimum samples leaf, the minimum number of data points allowed in a leaf node. The default value is 1. And then lastly, the bootstrap, which is the method for sampling data points with or without replacement. The default value is true, which considers that there will be bootstrapped model. So what does it mean? Let's understand through this simple example. Here we have the original data in the left, and randomly picked rows form a new dataset, which is called bootstrapped dataset. We see same row is picked twice and one row is missing in the new dataset, and this missing data is called out of bag sample. Yeah. So typically about 1/3 of the dataset does not end up in the bootstrapped dataset. Now let's quickly check the performance on our dataset with tuned hyperparameters. So at first we import the required libraries. Then we create a parameter grid. Here we have appointed values to every parameters to create the grid. Let me clarify some of the considerations. When maximum features is auto, it means there are no restrictions on the number of features. And when it is square root, this will place the value equal to square root of the total number of features. On each iteration, the algorithm will choose a different combinations of the features. Altogether, there are 4,320 settings. However, the benefit of a random search is that we are not trying every combination, but selecting at random to sample a wide range of values. Now, follow the same procedure like the previous tutorial to import the data, then processing the data and create a data frame and identify the important features, and then we remove other less important features. Then we split the data frame into training and testing set. We scale the weather data for a better performance, and then we found the score with the R² score for training set. It was 94% and test set is 88%. And here we considered maximum depth 12. With hyperparameter tuning, after 20 iteration, we find the best parameters, and using the best parameter, we check the performance of the model, and then we see the R² value is more than 97% for training set and around 90% for test set. With more iteration of 100, we find another set of best parameters, and then we see it is a perfect fit with the training dataset, and it is again 90% for the test dataset. It tries to reduce the error, so hyperparameter tuning leads to the perfect match with the training dataset. So the major parameter for overfitting in this dataset is the maximum depth. So we can conclude that the default parameters and the maximum depth of 12 for our dataset is satisfactory. So we don't need additional time for hyperparameter tuning for our dataset. So I hope this video is helpful to understand random forest machine learning model. So till next time, goodbye and have a nice day.